Welcome to the Deep Dive. Okay, let's dive into a world that's, well, incredibly vibrant, really diverse, and has a history maybe longer than you'd think. Chili peppers.
That's right. We've waded through quite a stack of your sources, articles, research papers, notes, covering, everything from where peppers came from ages ago, how to grow them, right down to the chemistry that makes them hot and how they end up on your dinner table.
And our mission here, in this deep dive, is basically to sift through all that info and pull out the really important stuff, the surprising bits that might just make you see peppers a little differently.
Yeah, whether you're chasing the heat or prefer things milder, hopefully there's something here for you.
Exactly. So let's jump right in.
Okay, let's start this journey. And we're going way back here. The Capsicum genus. It actually originated around 14 million years ago.
Oh, wow, 14 million. That's quite the backstory for something I chop up for salsa. What was going on back then?
Well, the sources point to capsaicin, the compound that gives peppers their kick as being really key. It developed as a defense.
A defense? You mean like, don't eat me or you'll be sorry?
Pretty much, yeah. That burning feeling. It warns off mammals. But here's the clever bit. Evolutionarily speaking, birds, they don't feel it.
Ah, okay. So mammals learn to avoid them, but birds are just fine, and birds, they tend to.
Exactly. They fly off, digest the fruit, and pass the seeds, totally intact, spreading the peppers far and wide. A brilliant evolutionary strategy, really.
And then, much, much later, humans show up in the New World.
Right. And humans, well, we're a bit different, aren't we? Apparently that burn didn't scare us off like other mammals. We tasted it and thought, interesting, let's plant these.
You got it. Domestication started around 7,000 years ago, and all that time selecting and cultivating, that's what exploded the variety. Shapes, sizes, colors, heat levels. It's kind of amazing.
Truly amazing variation.
And the easiest way to get a handle on that diversity is through the 5 main domesticated species the sources talk about. Where should we start? Capsicum.
Let's start with a big one, Capsicum annuum. This is like the most widely grown species on the planet. Think India, China, Mexico, the US. It's everywhere. Its wild ancestor, probably the tiny little bird pepper.
So wait, a sweet bell pepper and a fiery jalapeno. They're the same species. How's that possible?
It's all down to thousands of years of human selection. C. annuum is technically a tender perennial, but we usually grow it as an annual. Single white flowers, fruit starts green, ripens to red, yellow, orange, purple, you name it.
Okay.
What humans really selected for were things like fruit, staying on the plant, non-deciduous, right? And hanging down, not pointing up, plus appearance, obviously. And crucially, that huge range of heat, often selecting for less heat, too.
Makes sense. You want your big sweet peppers easy to pick, not falling off. Okay, what about species number 2? What makes it different?
That would be Capsicum frutescens. This one's often more shrub-like, comes from South or Central America. The really distinctive thing, visually, the sources highlight this. Its little, usually hot berries grow upright, pointing to the sky.
Pointing up. That is different.
Yeah, unlike most others we grow. The fruits are small, maybe 10, 20 millimeters long, less variety in shape than annuum, but they're known for adding heat without messing too much with the overall flavor of a dish.
Interesting.
And the species include some famous names, the Tabasco pepper, pie peppers, African bird's eye.
Heat without changing the taste profile too much. Okay, species 3.
Capsicum Baccatum, the name means berry-like, originates in Bolivia and Peru. Now, if you want heat and interesting flavor, this is often your go-to. The sources often describe the fruit as large, elongated, hot, but with this really distinct fruity, sometimes citrusy aroma.
Fruity and hot. That sounds like a fantastic combo. I wouldn't have guessed that.
It really is. The famous ají peppers in South America, like ají amarillo in Peru, that's C. Baccatum var. Pendulum. The flowers have these cool green or gold spots inside. Pods hang down, unlike Frutescens, and there's a huge variety of shapes and sizes. The plants can get tall, too, like 5 feet, and produce a ton of peppers. Think ají varieties, lemon drop, bishop's crown.
Okay, not for the really odd ones out.
Capsicum pubescens. Right away, this one is different. Its leaves and stems, noticeably hairy. And the seeds, they're black, totally black. It's native to the higher altitude spots in the Andes in southern Mexico.
A mountain pepper. Grows up high.
Exactly. Adapted to cooler weather. And get this, it can actually tolerate a light frost, which other domesticated peppers just can't handle. Not a hard freeze, mind you, but still.
Wow.
Its roots also get woody fast, so sometimes people call it the tree chili. Known as rocoto or manzano, that means apple because of the shape. It's the least common domesticated species, kind of reproductively isolated.
Black seeds, fuzzy leaves, frost tolerance. definitely stands out. And the last main species.
That's Capsicum chinense.
Yeah.
Now, the name is misleading. It's from the Americas, not China. It's closely related to Frutescens. This species is basically famous for one major thing: serious heat potential.
Ah, okay, so this is where the superhots hang out.
Absolutely. I mean, there are mild Chinense varieties too, but this species gives us the habanero, the Scotch bonnet. And yeah, many of the peppers that have broken world heat records, they often have white flowers, maybe with purple bits. Fruit usually hangs down, and sometimes you see this little narrowing, a constriction between the fruit and the stem.
You mentioned record heat. The sources brought up the Bajolokia, the ghost pepper.
Yeah, the ghost pepper. It held the record for a while, over 1 million Scoville heat units, or SHU. There's actually some scientific discussion around it. Some call it C. Chinense. Others thought maybe a hybrid with Frutescens. It was even suggested as its own species, Capsicum asamicum. It just shows how complex pepper genetics can get, even after humans have been messing with them.
It's just incredible, the sheer variety, evolution, then human hands shaping it. The sources even mention linking certain shapes to specific chromosome genetics in action.
It really is a testament to nature and, well, human curiosity and selection working together over a long, long time.
Okay, let's shift gears from history to getting your hands dirty. If someone's inspired now to actually grow some of these amazing plants, what are the absolute must-knows from the sources?
Top of the list definitely is planting. You've got to choose varieties that actually suit your climate and what you want to do with them. The sources do point out that if you're really focused on getting a big harvest and avoiding diseases, especially if you're growing organically, some of the newer hybrid varieties often perform better.
Right, but with hybrids, you can't save the seeds for next year. They won't be the same.
Exactly. You're buying new seed each year with hybrids.
Yeah.
But if you go for open pollinated heirlooms, seed saving is totally an option.
Okay, what about the ground itself, the soil?
If there's one huge takeaway about soil from these sources, it's compost, compost, compost. Seriously. Got sandy soil that dries out in a flash. Compost helps it hold water. Got heavy clay soil that turns into a brick.
Yeah, I know that one.
Compost improves the structure, makes it more workable, helps with drainage, gets air in there. It's kind of the universal fixer.
So compost is pretty much the superhero for garden soil.
Basically, yeah. Although, one little warning from the sources.
Yeah.
If you do have that really heavy clay, don't just dump sand in it thinking that'll fix it. Without lots of organic matter like compost, you might just end up making something like homemade concrete.
Ooh, good tip. Noted. And for starting the seeds themselves.
Right, because pepper seeds can be notoriously slow, sometimes uneven germinators. So give them a head start. Indoors under lights is common, or using window greenhouses, though, you got to watch. The temperature doesn't swing too wildly in those. Cold frames are another option.
Cold frames.
Yeah, like a bottomless box with a clear top. They can be temporary or permanent, insulated.
Mm-hmm.
You can even add heating cables underneath, turning it into a hotbed. That really speeds up germination. Then you grow the seedlings on there before they're ready for the garden.
And you can't just take those little seedlings straight from the cozy indoors out into the harsh world, can you?
Definitely not. That's where hardening off comes in. Super important step. You got to gradually get them used to the outdoors over, say, a week or two. Start with maybe some filtered sun, protection from strong wind, then gradually increase the direct sun and exposure. Cut back water just a little bit too. It toughens them up for the transplant shock.
Makes sense. Any smart ideas for laying out the garden, especially if your climate isn't perfect pepper weather?
The sources mention a few things. Modified irrigated beds sort of combines ridges and flat beds. Good for watering. Simple raised beds or planting in clusters works well too. Helps the soil warm up faster and drain better. And maybe the simplest but most vital tip: label your varieties when you plant them.
Oh, yeah. You always think you'll remember which one is which.
You never do, especially if you plant several kinds. Labels are essential.
For a lot of growers, the season just isn't long enough. How can you squeeze more pepper growing time out of a shorter summer?
Well, choosing the sunniest spot helps. South-facing slopes, raised beds get warmer. Row covers are fantastic, those lightweight fabric covers. They trap heat, warm the soil, protect from wind. Really good for extending the season at both ends.
Like little personal greenhouses.
Exactly.
Okay.
And then in the fall, if frost is threatening, but maybe there's a warm spell coming in Indian summer, you can throw sheets or plastic over the plants at night to protect them. Sometimes you can get weeks more harvesting that way.
What about feeding them? Are peppers heavy feeders?
Not excessively, based on the material. If they're growing in the ground with decent soil, they might not need much extra. Container peppers probably need a bit more help. A diluted liquid fertilizer or a slow-release type like Osmocote is suggested. Fish emulsion is a good organic choice.
Oh, okay.
One thing to watch out for, though, too much nitrogen fertilizer. You might get gorgeous, big, leafy plants, but fewer flowers and fruits. Or the flowers might just drop off. If you suspect that, especially in pots, the advice is to flush the container with plenty of plain water to wash some of the excess nitrogen out.
Interesting. The sources even touched on growing without soil, like hydroponics.
Yeah, it's definitely an option, especially if your garden soil is really unsuitable or you just want to experiment. They briefly mention open systems versus closed systems, and that growing bigger plants like peppers or tomatoes hydroponically has different challenges than, say, lettuce.
Like needing more room for roots.
Exactly. More root space, support for the bigger plants, and the nutrient solutions have to be tailored very specifically.
Is the timing different compared to growing in soil?
There is a table in the sources giving some typical timelines.
Yeah.
Something like 6 to 8 weeks from seeds starting until you transplant them into the hydroponic system, and then maybe another 10 to 12 weeks after that before you start harvesting peppers.
Okay. And you can't just use regular fertilizer, right?
No, definitely need hydroponic-specific fertilizers. They have all the micronutrients plants need, often higher calcium and magnesium, and they have to dissolve completely in water. You start seedlings on a weaker solution and gradually make it stronger as they grow.
All right, let's brace ourselves. Problems. What kind of trouble should a pepper grower be watching out for?
Constant vigilance. For weeds, corn gluten meal was mentioned as an organic pre-emergent, meaning you put it down before weed seeds sprout.
And bugs, pests.
Oh yeah. Aphids are common. Flea beetles make those annoying little shot holes in the leaves. Fruit worms can tunnel into the peppers. Stink bugs. Their damage can look like hail hit the fruit, but the leaves won't be shredded. European corn borers can be an issue too. And tiny little thrips. They're bad because they can spread viruses.
Viruses sound nasty.
They can be. Sources mention several, often spread by aphids. Pepper mottle virus, potato Y virus, PVY, was noted as the most common one affecting peppers. Then there's tobacco mosaic virus, TMV, which spreads mechanically like on hands or tools. So washing up is key if you, say, use tobacco products or handle infected plants.
Okay.
And then there are soil issues. Damping off kills seedlings. Fusarium wilt causes wilting. Plus various leaf spots like anthracnose or bacterial spot.
And sometimes it's not a bug or a disease, right? Just growing conditions gone wrong.
It's exactly. Disorders. Blossom end rot, that ugly black patch on the bottom of the fruit. Usually related to calcium uptake issues, often tied to inconsistent watering. Sun scald is literally sunburn on the fruit, big tan patches where it got too much direct, hot sun. Edema shows up as little bumps or blisters, often on leaves, if the plant takes up water faster than it can release it. And salinity salt, buildup in the soil, maybe from fertilizers or water, can stunt growth, burn leaf edges, even cause blossom end rot.
Wow, a lot can go wrong.
It can seem like it. But the good news, the sources remind us, is that your local agricultural extension service is usually a great resource for helping figure out what's going on.
They can help diagnose problems.
Good to know. Okay, let's move to the really exciting part, the reason peppers are famous.
Yeah.
The heat. What exactly is making that happen?
It's that capsaicin we mentioned earlier. It's a chemical, technically a crystalline alkaloid. It's produced in tiny glands right where the placenta, that whitish spongy stuff inside that holds the seeds, where that meets the inner wall of the pepper.
Okay, so it's made right there. Yeah, the highest concentration is in that placental tissue. It does spread into the pepper walls, but kind of unevenly.
And this stuff is potent.
Incredibly potent. And the sources emphasize how stable it is. Cooking it, freezing it, letting it sit around, capsaicin doesn't really break down. It also has no taste, no smell, no color itself. Pure heat sensation.
Wow. Stable and potent. So tasting isn't the best way to measure heat then?
Not accurately, no. Your mouth gets fatigued. Everyone's tolerance is different. For precise measurement, labs use a technique called high-performance liquid chromatography, HPLC. It directly measures the concentration of capsaicinoids.
Got it. And that HPLC measurement is what gives us those Scoville heat unit numbers, the SHU?
Exactly. It's a reliable way to quantify the heat based directly on the capsaicin level.
Yeah.
And yeah, this science has definitely fueled the sort of arms race for the hottest pepper. The Chili Pepper Institute was mentioned as being central to testing and confirming records, like when the Boot Jolokia first officially broke that 1 million SHU barrier.
So apart from the fiery excitement, are peppers actually, good for you, nutritious?
No, absolutely. They have real nutritional value. Here's a cool fact from the sources. As peppers ripen, say from green to red, and especially as they dry, their vitamin A content can skyrocket, like a 100-fold increase or more. That's due to carotene developing.
Wow.
Vitamin C tends to be higher in green peppers and decreases a bit as they ripen. But still, even an ounce of fresh green chili can give you a decent chunk of your daily vitamin C.
Right.
And just a teaspoon of red chile sauce might cover your vitamin A for the day.
That's impressive. Any other health perks mentioned?
Yeah, the sources noted potential benefits like aiding digestion, some connections to weight management that's linked to capsaicin again, and even possibly helping reduce blood pressure.
Okay, super practical question time. Anyone who's chopped hot peppers knows the pain. You get it on your hands, or worse, touch your eye. How do you deal with that burn?
Rule number 1 from the sources: wear gloves, especially with the really hot ones. That burning skin sensation, sometimes called Hunan hand, is a real chemical irritation. If it does happen, the key thing is don't just rinse with water.
Right, because capsaicin isn't very water-soluble.
Exactly. Water mostly just spreads it around, potentially making it worse.
Yeah.
Capsaicin dissolves in oils and alcohol, so the advice is to try rubbing vegetable oil onto the skin for maybe 30 seconds. Let it dissolve the capsaicin, then wash thoroughly with a strong soap or detergent.
Oil first, then soap. Okay. And for the mouth burn, if you bite off more than you can chew.
The classic remedy really seems to work. Dairy. Thick dairy is best milk, cream, yogurt, sour cream. Swish it around your mouth. The casein protein in dairy actually helps latch onto the capsaicin molecules and pull them away from your pain receptors.
Good to know. Essential knowledge for the heat seekers. All right, so you've grown them, you've handled them carefully. How do you make them last? Preservation.
Preservation is key if you have a big harvest. The main methods covered are freezing, drying, and pickling. Which one's best really depends on the type of pepper and what you like. For example, those thick-walled rocotos. Great frozen or pickled, but really hard to dry properly.
Freezing seems like the easiest route.
Probably the most popular, yeah. Just inspect them, wash them, dry them really well. That prevents ice crystals, and then double bagging helps avoid freezer burn. You can leave stems on or take them off. For thick ones like bells or poblanos, you might want to slice or de-seed them first.
And taking out the seeds and placenta reduces heat, right?
Significantly, yeah. Removing the placenta takes out the main capsaicin factory, though one source jokingly called that sacrilege if you want the heat. Frozen peppers definitely lose their crisp texture when thawed, but they keep their flavor and heat beautifully. Great for throwing into sauces or stews later.
And drying. That gives us things like those beautiful ristras you see hanging up.
Exactly. You can string fresh peppers, ristras, or wreaths and dry them in the sun, provided you have good air circulation. Just don't lacquer them if you actually plan to eat them later.
Right.
Smoke drying is another method. That's how you get chipotles from jalapenos. It involves roasting, peeling, then smoking them, often hung up for maybe up to 2 days until they're dark and brittle. The yield is pretty low. It takes about 10 pounds of fresh jalapenos to make just 1 pound of chipotles.
Wow, that's concentrated flavor. What about pickling?
Pickling works great for lots of types. Jalapenos, serranos, even habaneros if you're brave. The sources mention specific techniques, like sometimes soaking peppers overnight first to help keep them crisp, and poking holes in them before packing them in jars with pickling brine.
Are there other ways people process them?
Well, juicing was mentioned, believe it or not. Though the sources strongly advise wearing a mask because of the fumes. And dried peppers don't juice well. Roasting and peeling is common, especially for New Mexico-type chiles, but it can be fiddly with thin-skinned hot peppers. Steam peeling was mentioned as an option, but maybe not ideal, as it could apparently hurt the flavor and texture, sometimes giving a metallic taste. Fresh or frozen often seems preferred over canned for most cooking.
And ultimately, this all comes back to eating them.
Yeah.
The sources mentioned a huge range of culinary uses.
Oh, absolutely. Beyond the obvious, like green chili sauce, chili rellenos, chipotles in adobo, all kinds of salsas, pickled peppers. The list goes on. Sauces, rubs.
But also some surprising things.
Yeah. Like candied chiles for desserts.
Yeah.
Using peppers in chocolate fondue, or even chili-infused ice cream or pie. And don't forget, cocktails. A spicy Bloody Maria, maybe. From stews and tacos to pesto. Peppers really get around in the kitchen. It's amazing how versatile they are.
So quite a journey we've taken here from the deep evolutionary past and why peppers are hot in the first place.
Millions of years ago.
Through the incredible diversity humans created across those 5 main species, then getting into the nitty-gritty of actually growing them, dealing with pests and problems.
Understanding the soil, the climate, all that practical stuff.
Understanding the capsaicin, the heat, how to handle it, how to preserve the harvest, and finally, all the delicious ways to use them.
Yeah, we covered a lot. the sheer variety, the science behind the burn, the importance of knowing your growing conditions, and just how many ways you can keep enjoying peppers long after picking them.
It leaves you with a thought, though, thinking about how capsaicin evolved specifically to deter mammals, to cause that pain signal. Yet humans actively sought it out. We cultivated it, bred for more of it sometimes, even chasing extreme heat. What does that fascination, that persistence with the burn, say about us? About human nature, maybe our relationship with challenge, or just our connection to the plant world?
That's definitely something interesting to chew on. Why do we embrace the burn?